In this video, let us understand how the k-means clustering algorithm works. K-means clustering algorithm. Now in the previous video, we learnt about the prerequisite for applying the k-means algorithm. We need to know the number of clusters prior to the execution of the algorithm, and this we have already discussed. Now when we have the number of clusters that we want, the objective is to minimize the sum of the intra-cluster distances for all the clusters. Now there are some disadvantages of k-means clustering, that the results might not be the best, but it is advised to run multiple iterations of the k-means clustering algorithm, and whenever you get the smallest value of the sum of the intra-cluster distances, you should select that model. Now let us say we have a dataset with these features: x1, x2, x3. And here we don't have any output variable because we are making use of unsupervised learning. Now for each observation, what we will do is we will provide a cluster number. So let us say CNO, this is the cluster number. And what this cluster number represents is the cluster in which a particular observation belongs. Let us say we have 5 observations. So let us say for the 5th observation, which is this one. So this is first observation, second, third, fourth, and 5th. Let us say for the 5th observation, the cluster number is 1. Then this means that for the 5th row or the 5th observation of the dataset, this 5th observation belongs to the cluster 1. Let us say here we have cluster number 2, here we have 3, then 2 again, and 1. Let us say this is our cluster 1, cluster 2, and cluster 3. Let me label this as C1, C2, and C3. So here we have 4 and 5. In C2 we have 1 and 2. And in C3 we have 3, right? Now let us understand the working of k-means clustering algorithm. Now what we know till now is that using clustering we can identify certain groups that have a pattern in them. It takes out the complexity from the decision making process, and it allows you to identify those clusters, the clusters of data points in your dataset. Now k-means can work for multiple dimensions as well. Now let us understand the algorithm which is designed to find out these clusters for you. The very first step, as we had discussed in the previous video, is to select a value for the number of clusters. So let us take the value of k as 2. So this is the number of clusters that we want. Now the next step is to select at random k points the centroids that are not necessarily from your dataset. So let us say our dataset looks something like this, and here we have some points. And let us say some points are here. So the step 2 is to select at most k random points that may or may not be from your dataset, but they are going to be your centroids. Now let us say the first centroid is this, and the second one is this. Now we have to assign each data point to the closest centroid. So if you see these points, they are closer to this point and even this one. And if we talk about these points, they are closer to this point that we selected at random as the centroid for the very first iteration. Now the next step is to connect these two centroids with a line and find the midpoint. So let me use black shade and connect these two centroids like this. And let us say the midpoint for this line is at this point. Now at the midpoint we need to draw a perpendicular line to this line that we just traced. So let me draw it right here. Now any point that lies on this perpendicular line will be equidistant from both the centroids, this and this. So let us denote the centroids by labels. So let us say this is CE1 and this is CE2, right? So let us write this step down. So step 3, we assign each data point to the closest centroid. So that we can form k clusters. Here you can see we are able to form 2 clusters, and the initial value of k that we selected is also 2. And then after assigning each data point to closest centroid, we connected these 2 centroids with a line, which is this black line, and then we found the midpoint. Then at the midpoint, we draw a perpendicular line to this line, right? Now the next step is to compute and place the new centroid of each cluster. So you take these points that are lying above this perpendicular line and compute the centroid for this. And once you compute the new centroid for this cluster, the points of this cluster get displaced, or you can say each point gets reassigned to the new closest centroid that we get. And if any reassignment takes place, then we again go back and compute the centroid again. Otherwise, if no reassignment takes place and these points do not get displaced even by a fractional amount, then we can finish the algorithm, right? So let us write down the step 4. So the step 4 is to compute and place the new centroid of each cluster. And the step 5 is we reassign each data point to the new closest centroid that we compute. So if any reassignment takes place, we go to step 4. Otherwise, if no reassignment takes place, then our model is finally ready and we can remove the centroids that we selected and those equidistant lines, and finally we will get our clusters, right? So our 5 points are here and they form one cluster. And then here we have our 6 other points that are most similar to each other. So they form the next cluster like this. So this is our final result that we get after applying the k-means clustering algorithm on our data points, right? So in essence, this algorithm will keep on working until the displacement in the position of centroid becomes very small. And this is when we can conclude that the k-means clustering algorithm has actually converged. So this was all I wanted to cover in this video. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, hit the bell icon to get the notification for all the upcoming uploads, and I will see you guys in the very next one.